Now, dear children, we go to the next topic. Okay, and this is actually energy bands in material, or basically called as solid. Now, this concept is very important. Okay, as far as the classification of substance like materials is concerned, because in this particular chapter, the classification of any solid or material is based on the energy band. Based on what? Energy band. Now, let's try to understand what is energy band and how these bands are formed in a material or solid. It can be of conductors, semiconductor, insulator, anything. Okay. Now, a material or solid contain an enormous number of atoms. Yes, if I take any solid, like if I take a piece of what? If I take a piece of sodium, then that piece of sodium as a material contain enormous number of what? Atoms. And these atoms are packed closely together. They are packed what? Closely together. Now each atom and this atom also has isolated atom. Now let me just take the word isolated. Isolated atom means those atom, there is no other atom, neighboring atoms. So atom, there is only one atom. Suppose if I consider only one atom, there is no other neighboring atoms present in this atom, then such atom is also called isolated atom. So each atom, when isolated, has a discrete set of energies, electrons, energy level. Because we have learned the chapter Bohr's theory also. Okay, every atom acquire electrons. Electron acquired by every atom are in the different orbits, and every number of electrons in different orbit acquire different energy level. Okay, so if I take an isolated atom, okay, any atom, okay, then this isolated atom has a discrete set of electrons, energy level. That means the electron present in a different orbit acquire their energy, their own energies, and these energy are always discrete, a particular. Okay, but when n number of atoms, say suppose how many n number of atoms come closer to each other to form a piece of solid. Basically, the solid is formed by number of atoms which comes closer to each other. So if I consider there are n number of atoms, and this can be any value, come closer to each other to form a piece of solid, then energy state of each atom, see each atom energy state, which was discrete in case of isolated atom, shift to a little in its value. Shift to a little in its what? Value. Why? Due to the interaction of electrons. Due to the interaction of electron in the neighboring atoms. That means when one atom is very close to another atom, then there is an interaction between the electron, and even not only electron, there is an interaction between the nucleus and the electrons in the different orbits. And due to that, there will be some modification in the energy which was possessed by the isolated atoms. So what happened under this case? Energy state of each atom shift a little in its value due to the interaction of electron in the neighboring atoms, and this shift in the energy state of each atom, okay, due to the interaction of electron in the neighboring atom is due to the interaction of energy field. The energy field produced by every atom, and one energy field produced by one atom will modify the energy field produced by another atom. Under this case, what happens? When number of neighboring atoms come closer to each other, then every atom modify the energy field or energy level acquired by the neighboring atoms. Okay, so under this case, what happened? Each energy state splits into closely spaced n energy states. How many energy state? N energy state. Why n energy state? Because we are taking how many atoms? N atoms. If the n atoms come closer to each other, then all the atoms energy state will get modified by each other. So that means each energy state splits into closely spaced n energy state and forming a band. It forms a band of energies, and this band of energies, okay, acquired by the number of atoms, n number of atoms, okay, for every orbit, in every orbit acquired by the electrons is actually called as energy band. So in a simple way, we can define what is energy band. So energy band means basically for a given solid, closely spaced energy level of all electrons in a particular orbit. This is for particular orbit is called energy band. So we can define energy band as the closely spaced energy level of all the electrons acquired in n atoms in a solid in a particular orbits, and that levels of energy occur by the number of electrons present in a particular orbit in n number of atoms which form a solid is actually called as energy band. Now to understand energy band in more details, so we'll take one of the example. So let us consider the example of sodium atom. Now, so you know sodium is a metal which is a better conductor. So let's take the example of sodium atom. You know atomic number of sodium is how much? 11. So if number of atomic number is 11 means what is the number of protons? 11. And how many number of electrons are present? 11 only. So with this atomic number we can even write the electronic configuration. And we write this electronic configuration, children, in terms of block, S block, P block, D block and all. And you know very well this can be written as 1s2, 2s2, 2p6 and lastly 3s1. Because total number of electrons should be 11. 2 plus 2, 4, 4 plus 6, 10 and 1, 11. Okay, that means first block, 1s block contain 2 number of electron. The second 2s block contain 2 number of electron. P block consists of 6 number of electron. And lastly, the outermost, it is 3s block. And this 3s block contain 1 electrons in the outermost orbit. So for one isolated atom, if I take only one isolated atom of sodium, then this isolated atom of sodium has a discrete quantum state. Quantum state means the energy state. Okay, so occur by this orbits. Now see, 1s orbit has 2 electrons. So the energy occur by this 1s state has a discrete quantum state. So how many electrons acquire energy state? 2 quantum or 2 electrons. Okay, acquire this energy level. 2s also have 2 electrons present in this orbit. Okay, now it also acquire 2 quantum states. That means 2 electrons acquire the discrete energy level. 2p contains 6 electrons. So 6 electrons in this 3p acquire energy level, a discrete energy level. That means 6 quantum state acquired by this energy level. And lastly we have 3s which contain only 1 electron in the outermost orbit, and this also acquire a quantum state. So it basically with 1 quantum state means only 1 electron acquire energy level in the last orbit in sodium atom. But this is the case of isolated sodium atom. In case of isolated sodium atom, energy level acquired by all the free electrons or all the electrons in the different orbit have a discrete energy level. Discrete what? Energy level. But when how many atoms? N atoms come close to each other to form a solid. Okay, because solid consists of number of atoms which are come closer to each other. Okay, then their field interact with each other. That means their field interact with each other. As a result, among each energy state of this atom, quantum state of few atoms will go up and few atoms will go down a little according to the interaction between the atoms and its neighboring atom. So as soon as what happens when n atoms are come closer to each other, there is an interaction between the, as you know, interaction between the electron in the neighboring atoms, and there is an interaction between the electron and the nucleus in the neighboring atoms. Okay, so with this what happens, there is a modification in the field, electric field produced by each atom to another atom. So when this field get modified, that means energy level did also get modified. Okay, but it modify on the basis of how the number of atoms are interacting with each other. Okay, mean whether they are very close to each other or they are very far from each other. Okay, but as far as the number of atoms are come closer to each other, what happens among each energy state or occurred by these atoms, n number of atoms, quantum state of few atoms will go up, will increases. That means the energy level of few atoms in a particular orbit goes on increasing, and few atoms will go down a little, only little, according to the interaction between their atoms and its neighboring atoms. So under this case what happened, we see instead of a discrete quantum state occurred by the isolated atom, there will be a band of what? Energies, a quantum of energies occurred by n atoms. Okay, in every orbit. In every what? Orbit. That's why in place of discrete quantum state, we will observe n very close quantum state. n very close quantum state for each energy level. And this is actually nothing but the energy band. This is nothing but the what band? Energy band. Now if you look at the diagram, this is the energy level of sodium, isolated sodium atom possessed by the nucleus, with the first orbit where 1s contains of 2 electron present in this orbit, 2s again same 2 electron present, 2p 6 electron present, acquire energy level, and 1 electron in the outermost orbit 3s, okay, acquire a discrete energy level. But when the number of n number of atoms come closer, then every energy level, every orbit, the energy level acquired by all the number of atoms will not be same. Okay, that means there will be a band of energies acquired by all the atoms, n number of atoms in a particular orbit. That's why if you look at this diagram, these are the bands. These are actually nothing but the energy band acquired by n number of atoms in a particular orbit. So in the first, it will be 2n quantum state, the energy band acquired by n number of atoms, because in the first orbit there are 2 electrons, and such 2 electrons have n number of atoms, okay, so that they also acquire energy state, which is 2n quantum state. Similarly, second orbit, 2n quantum state acquire comprises of n number of atoms, okay, in a particular orbit, second orbit, acquire this energy band. Similarly, 6n quantum state acquire energy band in this 2p orbit, next orbit. And similarly, if you go to the last orbit, the outermost quantum state acquired by actually n number of electrons, because each orbit, the last orbit has 1 electron. That means if n atoms combine, means basically n atoms, but this orbit has a maximum number of energy band, okay, or more energy band acquire due to the more magnetic field or more electric field get interact with the neighboring atoms. Okay, that's why the splitting of energy state from isolated atom to energy band of sodium atom, sodium solid is given by this diagram. But one point you need to keep in mind, the splitting of each quantum state is more in outer energy state, and less or sometimes negligible in inner energy state. Because in inner energy state, okay, interaction become very less between the electron and the nucleus, whereas interaction become more maximum or possible in the outer state. So there will be more energy state, more energy band modified, okay, in the outermost state as compared to the innermost state. Okay, so this diagram is the energy band diagram of sodium atom acquiring different energy levels in different orbit, and this is the energy level acquired by the isolated atom. So with this isolated atom we can make sodium atom, we can make an energy band diagram of sodium atom. So similarly we can draw the similar isolated energy band diagram for any of the solid, whether it's for semiconductor, we can do for insulator or any solid. So this is the concept which is required for energy band in solid.